So for this review exercise, and this is going to help prepare you for the assessment and review everything that we've learned. Just like the car manager program, we're building a school manager program where we're going to print something to the terminal. There are different options that you can choose from, list all students, view individual students, add students, remove students. Wait, the tutorial actually walks through this. I'll sort of have this as a bit of a guide, but I'll sort of be building it out and talking about it and also demonstrating sort of how to make some of these design decisions, even though we give a lot of this to you. So the first thing you always want to do, like when you're given like a project or like the assessment or something, is read through the instructions and also look at the code that is given. And we give a little bit of code here. There's a school class, so I know I'm going to have to write a class named school that lives in this file, school.py. I know that my main method, I want to be in this runner program that's going to import my school class, and I'm going to want to do most of my stuff here, and I might create some other classes along the way. And then here in this data file, there's some CSV files, and it's always good to look at your data files to get a sense of the shape of the data. And I'm going to look at the raw CSV. The preview's nice, name, age, role, employee ID. So this gives me, what this tells me right here is the different kinds of people I need to create in my system. So, there's a principal, there's a janitor, there's a teacher. So I'm not sure if I'll end up making like a different class, maybe with a little bit of inheritance for each of these roles or exactly what, but it's good to see. And then, of course, we also have students, right? So there's staff and there's students. So already I can start to get a sense of what my classes are going to look like. And I think we'll come back to the data in just a moment. We're going to start out for this first part. We're going to create some classes. It's going to look like this school class. We're going to create a student class. We're going to create a staff class. And then we'll get here to a little bit of refactoring, but let's start out here. And let me also kind of walk through how to go about this if you didn't have the tutorial. So first off, I'm just going to go ahead and clone this. I'm not going to worry about pushing code right now or anything like that. And I'll fix the sort of repo inside a repo issue later. So you probably don't, if you're coding along, you can clone and change the remote later. I'm not going to worry about that right now. Though, in fact, I think what I will do for myself, don't go ahead and copy this, is I'm just going to delete the .git directory because this already lives inside my demos and notes repo. So let's open up school.py. And let's open up runner.py. And I'm going to go ahead and I'm going to make a notes file. And in here, I'm going to make some notes about what I want to be doing. So what are the things that I need to do, right? What's my task list? I need to make the school class real. Let's take a look. We've got staff and students. So if I'm looking at this, I think a good starting point is we probably want a students class and a staff class. So we're gonna at some point want to make students class, and we're going to want to make a staff class. Create students from CSV data. And we're going to want to create staff from CSV data. And in here in sort of a question mark, do I want a person class that students and staff inherit from, right? And if I look at staff, I've got name, age, role, employee ID, and password. So I know that my instance attributes are going to be name, age, role, employee ID, and password. And if I look at the data for students, I can see that the instance attributes for this class will be name, age, role, school ID, password. Right. So what I see in common here is name, age, and role. So maybe I do want a person's class, and we'll just call this 1.5. Make a person class. And let's say this one will have to be a parent class. And I'm not going to get into the fanciness of abstract base classes or anything like that because I don't need to right now. I'm just going to keep it simple. Name, age, and role. And student will inherit from person, and staff will inherit from person. Right. So again, kind of the more upfront design work you do, I think the easier it makes your life. And in fact, I can make some notes here. Age is going to have to be an integer, right? Age is going to be an integer here. School ID, if I look at student CSV, staff ID, these sure do look like numbers. Sometimes IDs you don't want, they're not numbers, but in this case, I think they are. So let's make that an integer. And as I get deeper into the assignment and on the assessment, we have a pretty detailed spec about how things should be. But it's always good to look at the data because sometimes there's like exceptions or like edge cases in the data as well. And if I look at the names, I just see that there's like first names here. There's nothing fancy, right? So I'm not going to worry about it too much. And for the staff, the role will be staff, or it'll be different for each staff member because there's principal, teacher, janitor. So role is not going to be hard coded. But for students, all the students have the same role, student. So we're going to hard code the role for our students. So if I go back to the assignment spec, we haven't written a line of code and we haven't gotten to the terminal interface or the school class, but we've actually done an awful lot of design of what our program is going to look like. And I can get an awful lot of functionality out of this with the student class that's using the person class and the staff class, right? The other features is we're going to need the terminal command. The terminal commands, we're going to want to make a school class shortly. So let's start digging into this and going. And this is where I think I will use a bit of this guide because we don't have a spec to work off of because this is built as more of a tutorial. So let's talk through this. So if this was, say, an assessment, we wouldn't be giving you the code, but we would give you a spec that would say the class school must have the following instance attributes and the following methods. So just for consistency's sake, I'm gonna write out my design in my notes too, because I really like having this. And also because then when I get this done, I get to tick off the tasks, right? So my instance attributes here are going to be name, staff, which is going to be a list of what? What is going to go inside this list of staff?
Be
It,
roles. Oops, sorry.
roles is one option. What are
I
some
was just
other
gonna say
thoughts?
ID.
IDs, that's another option. What are some other thoughts?
Would it be maybe like a list of dictionaries with the well, yeah, a list of dictionaries with each key value pair like the header. So like, name and then the value would be their name and then the role and then the value would be their role.
That's another option. Um, Big picture, without thinking about like the code, like what's the goal here in having like a list of all the staff that work at the school?
Would you not just do a list of the actual staff objects?
Yeah, I think that's what we're probably going to want to do. As we get into this, we'll see like if the sort of the tutorial takes us in a different way. But right, and to put a little code here, remember like, teacher one equals, I'm making this up, but my school staff append, right? I can create an instance of a staff member with my class, and I can just add that to the list. And what's the advantage of doing this versus a list of staff IDs or dictionaries or the other things that people were suggesting?
You could just access it by like throwing in maybe like the ID or like you could access it much easier and then like the reproduce or the string methods inside of those classes will just make a much more readable like print for them and then you could just access an instance of that object by index or something like that and then you can much more easily alter them or just work with them from outside versus having to like use a bunch more methods to like loop through and find the keys or so to speak.
Yeah. And I mean, you raise a good question. Like, what if I want to find a specific staff member? With the list, it might be a little more work. The flip side is, what if I want to print out all the staff members at the school? If this was a dictionary, that might be a little more work. And so in this case, we can just sort of assume the spec is giving us like, give us a list of all staff. But I think that design choice of what I want this to be a list or a dictionary is always a good one to think about. But a lot of the times for assignments and the assessments, we're gonna give it to you, right? And so the advantage here is that I can get, it, I can grab a teacher from here and I can use all those class methods on that teacher if I wanted to, right? Like if I could do, my school staff zero and I don't know, role, right? And I can see the role of that person in my list of staff. And the list of students is probably going to be the same thing. And I just want to check in to see if folks have any questions. Okay, cool. Let's start writing some code and making this real. But hopefully also you can see how like taking this time up front to do some design saves you time and work. And it like thinking about stuff like this before you write code actually takes less time than dealing with it when you're writing code. Because then you write the code and then you try to go backwards and figure out if you made a good or a bad decision. So like you might want to spend like 30 something minutes with the assessment, like just walking through it and sort of planning stuff out. And also now I know what I need to accomplish. I can keep track of my progress and like keep track of time. So I've really set myself up to do well here. So let's go ahead and build out this school class a bit. Now, again, we've sort of been given the code here, but we can, assume that we have a spec. And I'll just, we're going to want a name. We're going to want staff. We're going to want students. And in this case, I'm not going to worry about passing in a list of students or teachers when I create a new school. We're just going to initialize with an empty list, like someone was saying, asking about yesterday. I'm going to go to my runner, and now I do want to run my code and make sure that it works. Let me make sure I'm in the right file. And the school name works. Just for fun, let's print school.staff and school.students, even though I know no one's in there. But I just want to make sure I don't have a typo. I've got 2 empty lists and we're good to go. And now let's go ahead and create our students. And here, yes, the code is here and staff is here, but we've actually already done a lot of design work. So, and in fact, we can see this is kind of where we're going. Let's just go ahead and build out. So we've made a school class. It's got name, it's got staff, it's got students. Really, this one, for the time being, is good to go. Let's make a person class. And for this, I think what I want to do is make a file just for my class, because that's how I want to organize my code. And I'm going to write a little comment here just to remind myself what's going on. And if I go over here, I want a name, age, and a role. So let's go ahead and write our constructor. And for the moment, I'm not going to worry about getters and setters. I can always add those in later. Though age, since it needs to be an integer, maybe that might be a nice one to write a getter or a setter for, but we'll come back to that later. And I think what I will do is I will cast age to an integer here and just add a to do. Validation. Handle cat error. Cast error if age invalid. And I'm not going to worry about that. And I'm not going to worry about validation logic. Validation, once you get your skeleton code and your core functionality working, that's the right time to add validation logic later. So now I've got a person class, and that's really all that we needed for our person. And so now that one is done. I think I'll pull that up here as a reference. And what do you all want to do? Should we make the student or the staff next? How about students? So that one I think is simple. Oh, I'm sorry. Someone was going to say something.
No, you're good. I just said student. I said the same thing. You're good.
Great minds. I love it. So first off, from person, import person. And I'll just put like a student class. Right, and let's go back to my notes. Let's copy what I need to know here. Student class is going to have name, age, role, school ID, which is an integer, password, and we're going to need to be able to create the student from some CSV data. But let's just get this class going. And actually, I apologize. I should have followed my own advice about always testing my code as I go. And I'm going to write a quick test here. to create a person. Let's do Bob. And what I'm going to do for Bob is pass in an integer, because maybe that I think with the CSV data, it's always going to be a string, but I want to make sure casting an integer to an integer doesn't throw an error. And actually, what I would really like to be able to do is just do like print Alice and print Bob and confirm that my code works. Let me go ahead and do that. And let's test that real quick. Python person.py. So not so useful, right? Can someone remind me, what do I need to do so that when I print out Alice and Bob, I get some useful information?
You need a dunder
Dunder
string.
string.
Yeah. Though I know that Alice and Bob are going to end up in my students list. So what's the other method that I need if I want to print out a list of people and get useful information?
Use a getter.
reproduce
Not a
method?
getter, but there's
Repr.
two
Repr or
Yeah,
dunder.
there's the two methods that will print out string representations. And I know this has been a point of confusion. Repr gets used for everything. Like, and in fact, let's go ahead and just demonstrate this really quick. So if I had just done dunder string, and I'll just return a f string of name, self name, and age, self age, and role, self role. So let's see what dunder string does and doesn't do for us. I feel like I did something silly here because,
str instead of string.
oh yeah, that would do it. Thank you so much. Okay, good teaching moment here. This is the worst kind of mistake to make because nothing broke. I don't even have an error message that gives me useful information. So I'm really glad that you pointed this out. The best advice that I have is if you're debugging in a situation like this, you have to take a break, walk away from the screen for like 5 to 10 minutes and come back so you can look at it at fresh eyes. Or sometimes you just have to comment out or delete the code and rewrite it because sometimes it is hard to see the error. But if you do it again, then maybe you don't make that mistake. So indentation, oh, because this is still commented out. So dunder string works great for my print statements, but what dunder string doesn't do is when I have these instances of my person object in a list, I'm not getting their information printed out. REPR is short for representation, meaning the universal string representation of this program that Python will use all the time. Dunder str is a little more limited. As you saw, Python uses it when you print the thing. But if you print like a list that the thing is inside of, Python doesn't use it. So I would just go ahead and make dunder REPR, and that's really all you need. Like, and if you want extra information when you print Alice and Bob to like make it friendlier for whatever reason, maybe for the user, then the dunder string method would be used there. So like if I do just to show as an example, for the print statements, we get extra stuff. So if we want like some extra nice human readable information, we can use the dunder string method. But for our purposes, really, I just want dunder str, REPR. So this is great. I've tested my person class works. I I highly recommend doing this on the assessment, like for every method function, like every 5 lines of code that you write. If the test suite doesn't cover it, use print statements to confirm that the code you wrote doesn't have bugs, because then the bugs are small and easy to fix. And now that that's working, I am just going to comment all of this out. Actually, let me just pause and check in and see if folks have any questions. Okay, cool. Let's go ahead and build our student class. We're importing a person. The student is gonna take name, age. We know that the role is always going to be students. So, but I also know, I kind of remember, like, if I go look at my CSV data, the role is here. And because I know that I want to be able to use the CSV data to create a student, this is going to be one of the arguments, and this is going to be the next one. So I think I'm going to put role in the constructor for now. Maybe I'll give it a default of students. I'm not even going to do that, actually. We can come back to this later. Maybe we'll end up using a class method for an alternate constructor. We'll see. And then we have school ID, and then we have password. And I want the student class to inherit from person. And I want to use the constructor of my person class. So let's call the constructor of the parent class of this student, which is the person's constructor class. And here, we will just pass role in, since we're taking it as an argument. We'll worry about maybe, maybe I want to hard code this to student, but since we're taking this in as an argument, and since it's in the data, I'm not going to worry about it too much right now. And now the two things that the person doesn't have that the student does is a school ID and a password. So self school ID equals school ID. Self password equals password. Right, and let's test this out. And we said that the school ID is an integer. So let's go ahead and make sure we cast that to an integer, and then the password. And let's print out Alice. And when I print Alice, what do you all think we are going to see printed out to the terminal?
Maybe whatever was in that reproduce method from the parent class.
I think so as well. I'm not 100%, but I think that's the case, since our student class is inheriting from the person class, which means it inherits all of the methods we create here. I think that when we print Alice, it will use the Dunder REPR representation method, which will give us name, age, and role, though not school ID or password, since that's not in here. I'm not 100%, but let's see. Attempted relative import with no known parent package. I think I just made a mistake there. And let's try just dot person. I don't think we need. So I fixed the relative import issue, but now I have another issue. Actually, I didn't make this mistake on purpose, but can anyone help me out and point out what my error is and maybe how to fix it? It says person dunder init takes 4 positional arguments, but 5 were given, and it's happening here on line 14.
I don't think you need to put self in the super init.
Yeah, I don't think so either. I always forget about that. And the same way, you know, when I create a new instance of the student class, which calls this init method, I don't pass in self. We're calling this init method, so I don't have to pass in self there either. And the clue, by the way, is it says takes 4 positional arguments, but 5 were given. And that tells me that there's an extra one here, and that kind of tells me, hey, I probably don't want self there. Yeah, good call. Thank you. So indeed, we get Alice's age, name, and role. But I want a little more, right? Because I want Alice's school ID and I want Alice's password. So, you know, we might not want to print the password out in the real world, but for our purposes, we will. So we need this dunder REPR method. Now, if I wanted to get fancy, I could do something like this. I could call the REPR method of the parent class, and it returns a string, and I could append more stuff to it. Actually, we can. This is a little fancy, but let's see if it works, because it is kind of nifty. To be honest, the easiest thing is honestly, I would probably just copy and paste this and add the extra stuff. But let's see if this works. Let's see how we do. And actually, it did not like that at all. Which, yeah.
Does it need parentheses after the RP?
Oh, after the REPR to call it, it might. I think you're right. This, I think, so if this works, this is a great example of even if it works, it actually may not be a good idea. So it does work. And DJ, that was a great call. Thank you. I actually have to call this method. Like, you know, if you look at this, the question is, how readable is this? And in this case, maybe a little duplication is worth it because it makes it way more readable and it gives me more control. So I'll just leave a note here. Maybe too fancy, but this does work. And I'll just do it the other way. This also gives us a bit more control if we ever want to modify this. But it is cool to see that we can do that. That super method gives us access to all the methods on the parent class. And DJ, great call that I had to actually call the dunder REPR method. And so now I've got a student class, takes a school ID, a password, it inherits from person. The REPR method is working. We've seen how if we want to get fancy and really leverage inheritance, we can, but there's also the more straightforward approach, and we've tested out this code. Let me go ahead and make a staff member. And I can almost follow the same pattern here. So I am in fact going to copy this whole thing. And paste it. The only thing I will say is reusing your own code as guide code is great. It is surprisingly easy to make mistakes in modifying it. So sometimes what is actually better than copying and pasting like I did, and I copied and pasted in part in the interest of time, is pull up the code that you want to use as your guide code and type it out, the changes that you want to make in another one. And that's actually what I would recommend doing most of the time. And I've got here with my staff member, and again, here you can see like doing that little bit of design work makes life really easy, because it's like, I can't be my own navigator and driver at the same time. But if I do a little upfront design, then when I'm writing the code, I can focus on the driving. I don't have to do the navigating and the planning. And this is employee ID, not staff ID. And this is why I don't recommend copying and pasting like I just did here. I highly recommend writing it out. Even if it feels like it takes longer, what ends up happening is you miss one change that you have to make, and now you have a subtle bug that takes like 30 minutes to fix. Oh, and I do see a question. Tyler, yes, sir.
Yeah, I was wondering, maybe I missed it, or maybe I don't know if you're doing this just to kind of demonstrate like inheritance or whatnot, or maybe there is a specific reason. But I was just wondering why you would want to make a person parent class and then have separate classes for like staff and student. Because my initial inclination is that like the role is all we really care about eventually when it comes to like adding these people to different classes or different lists.
There's a
So
lot of
what?
different ways to design this. This isn't necessarily the one right way, but the reason I chose to do this is because students, oh, I see what you're saying. You know, you might be right. We might not need this, because you make a good point that the role is right now the only significant difference. Though actually there is a bit of a difference, because employee ID, if we go back to our notes, actually we can take a look. Students have a school ID, employees have an employee ID, and even though it's both a number, they're used for different things.
Okay.
Yeah, right now there's not a lot of changes, but as we get into it, like students might end up having methods that are unique to students and staff to staff. So it's a little bit contrived. You're correct.
Okay, that was kind of what I was getting at, as I was trying to think about it, and I figured I'd just ask. But that it does make sense to me in that sense that they would have different methods and different, because I remember like in the README, like your access level is principal. It's like there's going to be permission levels and stuff. So
Yeah, we'll see.
Okay.
Yeah, but no, that's a good question, and that's a good call. That really, this is a little bit extra right now,
thank you.
for sure. Yeah, and also to be totally honest, part of the reason we're doing it is to review inheritance. So now I've got students and staff, and I've got a person class. Let me go ahead and just move my test code into my runner file and import all this stuff, since I know that I'm probably going to want to use it all. So we've got Alice, who's a staff member. Let's put that stuff there. And if I go to students, we're going to have to change Alice to Bob, so I don't have two Alices. And we've got Bob, who is a student. We've got staff and students. And now in my main runner method, I've got my little test code, I've got my print statements, and we're off to a good start. And now it's kind of a good pausing point, because I've implemented a lot of like core functionality, right? We've got students, we've got staffs, we even got a bit ahead. They both inherit from a person class. If we look at what we're interested in doing next, we're talking about doing a little bit of refactoring to use this special star quargs that we saw very briefly to take student information in as a dictionary. And I think we'll go ahead and do that. And part of the reason we want to do that, if I'm jumping ahead just a bit, is we're going to be importing our CSV data in here. So this might be a good pausing point, actually, because there's a couple next steps here. And actually, let me review this to see kind of where we want to go next, because I might want to break you all up to do a little bit of independent work. So I think I'm going to hold for the moment on this, but I do want to demo just a little bit of refactoring of how we organize our code, because that will be helpful and that will set you up to get more comfortable with imports for the assessment. So let's make that change now. So I'm gonna get rid of all of these other tabs just for some simplicity and readability, and I'm gonna open up this as a reminder of our structure here. And right now, you know, there's this data directory, and there's the README, and there's runner, and there's school, and there's staff. And what I want is, I want to create a directory named classes. And I want to move all of my class definition files into there. So let's move person into classes. You can drag and drop if you want as well, but I think the command line is good practice. Let's move the school class into classes. And let's move staff into classes. And let's move student into classes. And it would help if I told it what directory I wanted to move it into. And as your programs get bigger, it can be nice to have like one file per class. I know folks were asking about that much earlier in the week. And for the assessment, we will kind of give you instructions on how to do stuff. And now I do have to, and now I have my main method runner py over here. And note all of these imports are broken. So we do have to make that change now to tell the runner where to get stuff. And in Python, thankfully, that's very simple. Python looks at a directory name as sort of namespacing. So when we say, hey, find this school module, right? Because every file in Python gets turned into a module. We can say Python, go inside the classes directory or namespace. And note that I got some really nice autocomplete here. Import student. From staff, import staff. And I'm going to run my runner again, just to make sure that all this works and my imports are still good. And it looks like I did run into an issue. It says module found error, no module person, and it is coming from the school interface and the student interface. So let's tackle one of them first. Let's do the student one first. Actually, let me do this real quick. And let's see what's going on. And I'm going to make this even easier to debug. Let's just run this student py and see what happens. So that actually works fine. But then in my runner, I get an issue. Any thoughts about how to resolve this? This one is a little trickier.
Is it because you haven't imported person to your runner?
We might need to import person to the runner. Though we do import person in the student file. So I am a little surprised that we ran into this error actually.
Is it
Yeah, please.
is it just because your runner file is outside of the I mean I know it's in the same folder as classes because it's outside of the folder, the separate folder you put all your classes in?
When
I
I
think-
changed
Yeah, go
my
ahead.
when I changed my import into staff and student, because I kind of ran it and I got the same error, but when I changed it to the same namespace in classes.person, import person, even though it was in the same folder, it worked.
Yeah,
I don't know why.
yeah. I think this is the way to do it, and I'll talk in a moment about why. There might be some other way to do it, but I think this is the right way. So if we do this for staff as well, I think this will solve it. And in a moment, I'll talk about what's going on. And there we go. And stuff is working. So this is interesting, right? Even though school and staff are in the same directory as person, to get it to work, I still had to do from classes.person. And I believe what happens here is in a runner, when Python runs this, it says, cool, let's import the school class, but it doesn't really do anything with the school class. Actually, I'm so sorry. Import the student class. And it doesn't really do anything with the student class until we create a new student. And at this point, Python actually executes the code in our student class. And let's do a little split here and bring student up here. Well, when I'm running my Python program, runner py is in the root directory of my project here, right? So when we create the student, the Python program is being run outside the classes directory, right? Where I'm running runner py. And so then this happens, this actually gets executed outside the classes directory. And that's where I think that causes the problem. What you're seeing here is what's called an absolute import. Like this is the path from the root project. So I can put this anywhere and it should work fine. And I think that's what's going on there. And like if I moved the student file out of classes into the main one, it would work fine. But so the rule of thumb here is for imports, when you can, try using an absolute import, which is the path from the project root directory to where the file lives. Not, which this, by the way, used to be an absolute import. I think if we do that, it might work as well. So this is a relative import. Remember on the command line, cd dot this is relative to the current directory. So this does tell Python, hey, from look in the student directory, look in the classes directory for person and import it. This says Python, look in the root directory of the project for person, but person is no longer there. So I might have misspoke a little bit earlier. It's less about where it's run from and more about if you don't have a dot in front, it's a absolute path. With the dot in front, it's a relative path. I recommend just using the absolute path. Let's go ahead and take let's take a 7-minute break and just come back at 10 o'clock Central, and then we'll keep writing code. Because I think either kind of maybe I'll demo a little bit with CSV, and then maybe we'll break up and do some individual work time and then reconvene to kind of take this home. How does that sound to folks? Cool. Before we break, any quick questions around maybe like syntax or anything like that with any of the code that we've been writing? Okay, let's take a break and I'll see everyone on the hour. Thank you. Okay, so we've got our runner, and just to review, we were talking about absolute versus relative paths. Actually, that's a good one to very quickly review, because I think that's a bit of a tricky one, and I kind of led us down a little bit of a wrong path there. So we moved all of our classes into this classes directory. And remember, we ran into this issue where for, say, my staff class, we were importing the person class, but we were getting an error, right? It said it could not find it when we ran runner.py. And the reason was, now that we've moved the person class into the classes directory, we need to change our import path. If I start my import path with a dot, that's a relative path. And Python namespaces directory name to file name. So this says in the current directory, look that the staff py is in, look for a module, a file named person, right? Without a dot in front, we have an absolute path, which will say, like, when we run, say, Python runner py, which is outside our class's path, look in this directory for person, and it's not in there because it's inside classes. But if I do this as an absolute path, then this will work fine when I run Python runner py, because it will look inside classes and then find the person path. So I just wanted to review that just a little bit. And if we kind of just recap what we've done, we've got school, we've got student, we've got staff, student and staff inherit from person. And we're creating some students. And just as a sanity check, I'm going to run this again, make sure everything works. And let's see what we have up next. So what we're going to do now is sort of preparation for importing from our CSV. And in fact, I think, oh, Francisco, thank you so much for the comment. Yeah, please ask any questions about paths, because if I was inadvertently confusing or if something didn't make sense, now is the time to tackle it and discuss it. And Francisco, I don't know if you have a recommendation for like the absolute versus the relative path. Relative paths make life easier. Yeah. I think there's something to that. Right, so I can change for student and staff. I can change this to a relative path to say, hey, like, staff py, look inside this directory where you are to find person. And now, in fact, if do I have a student in here? If I run classes student py, attempted relative import with no known parent package. Yeah, there's no way to escape it. Like, once you start creating more structure, it can, I think, start to matter where the paths are. So that's also like, once you start like having more directory and project structure, you want to get more consistent in how you run your program. Like, now I have things set up that work great whenever I run runner py. So that's just what I want to do all the time. And let me quickly just catch up on comments in the chat. Yeah. Let's talk about loading data and see what that looks like. And for that, let me pull up our runner py file and let's dig into this and experiment a bit more. I know folks were asking about importing with CSV. So let's look a little bit at that. I'm sorry, bear with me just one moment here. So in my runner py file, I'm just going to get some prototype code going. And we can see what this looks like. And then we'll maybe add it as a class method or something like that. So when we want to open a CSV file in Python, we can use this with argument and then open. And we get this incredible description of what this open method does and what we should pass in. And we need to pass it the file path, and we need to tell it if we want to read or write. So just for the moment, I am going to hard code this in. There are ways where you can, and note that I'm hard coding it in with a relative path. So this is going to open relative to where runner.py is. And that is in /data. I don't know why I wanted to do that. /students.csv. So I'm giving it the path to the file, the relative path to the file that I want to open. And I am going to pass this argument, new line equals that. And if we hover over this and we can kind of see what this actually tells us what all this stuff does. And somewhere in here is hiding the new line description. Actually, let me just. Yeah, this just specifies like what indicates a new line in the CSV file. Let me come back to that one as we're digging into this. I don't want to get too lost in that right now. And then I think we also do want to tell our program that we are read only. So I think I will pass the read mode argument. Though I do believe that is set to read by default. Python has a great built-in CSV library that's part of its standard library. And I'll just add all the way up here, import CSV. Just so we don't get like squigglies about stuff. And it has this class that we can use called DictReader. And so I'm using with to tell Python the relative path to the CSV file I want to open, that I want to open it in read-only mode. And I'm not 100% sure if we need this, but I'm also telling Python how to tell when a line ends in the CSV file. Because some CSV files maybe use a semicolon as a line end. And then with as, I'm saying, hey, when you open it, let me interact with that file using this variable named CSV file. And then let's use Python's built-in CSV class that also has a dict reader class that will turn each row of the CSV file into a dictionary. So open the file, turn each row of the CSV file into a dictionary. And what's really cool is with this reader, we can use a for loop with it. And for instance, let's just print this out just to see what happens and just to make sure I don't have any errors in my code. So, right, we use with to open the file with a relative path. We tell it we're in read-only mode. I don't even think we need this new line here, but it certainly doesn't hurt. We assign the file to a variable name. We tell Python, use a dictionary reader. So we can go through, we can loop through each row in our CSV file and turn it into a dictionary. And I can see that printed out here. So I just want to pause and check in and see what questions folks have, because this is a good one to chat about.
Do you always call it reader as the variable name, or do you specify different names?
So just like creating any variable in Python, whatever's on the left side of the assignment here, unless there's something else going on, I can name it whatever I want. Though I know with like with getters and setters, like there's every now and then there are exceptions to that rule. Reader's just an easy one to name it because it's short and it's related to dict reader, so it tells us what it is, but we can name it whatever we want. Yeah, that's a good question. What other questions do folks have? And similarly, this is just a variable that I've created that I can name whatever I want as well. So,
Yes.
oh, yes,
Adam.
please, go ahead.
Yeah, is that dict reader, is that formatting that into the, what's the output, like a name, the keyword value thing, is that formatting it with that dict reader method? Or was it already like that in the CSV file?
Do you mean with what sort of formatting are you referring to?
Like the dictionary format where it says name, Lisa, age 25, like
Yeah,
the keyword value.
so this is the file in question, a CSV file. The first row for most CSV files has column names, essentially separated by commas, name, age, role, school ID, password, and then values, right? So here for row 4, name Slater, age 25. What dict reader does is it looks over this whole thing and it turns each of these into a dictionary where the key is each of these column names and the value is each of these values. Does that answer your
Okay, thank
question?
you. Yes.
Awesome. Yeah, great question. So we now have a dictionary, but our student class doesn't take in a dictionary in its constructor, right? It takes in these individual arguments. So luckily, Python has this sort of built-in feature to the language that will let us turn a dictionary into individual arguments and into individual named arguments. Now I do need to do a little bit of modification here. I want to make each of these named arguments. And now what I can do is pass in the row, and instead of row, let's name this student data, right? Because that's what it is. And in fact, I'm going to go ahead and rename this, and we'll call it, let's just call this student reader. We'll call it student data reader. And now my names make sense. Student data relates to student data reader. I don't like naming something lowercase student when I have a class that is student with that starts with a capital letter. That's too easy for me to make a mistake. So I'm going to name it student data. And now my code is really readable. So let's watch what happens if we try to pass in the dictionary. This is going to produce an error. And it looks like there's a couple different errors. If instead I put these 2 stars, it is going to break up that dictionary into individual arguments and use these named arguments to assign them, sort of like destructuring in JavaScript. So if you all remember, like way early on, we had seen it was like star fargs if we wanted to sort of pass in a whole bunch of keyword arguments of whatever we want. Well, these 2 stars in Python, what it does is it says, hey, take this dictionary and break it up into a bunch of individual variables where each variable has the name of the key. And because I converted my constructor to take named arguments, Python knows which each one belongs to. So this is a really nice technique. And I want to check and see what questions folks have. Tyler, yes, sir.
So I tried it without doing the name equals none. And it
Did it
looks
work?
like it did the same thing. I just can't quite tell. I was trying to figure out with the print statements.
Oh, I
If
may
so,
be wrong. We may not have needed to convert this stuff to named arguments. I'm
well, I
not
was just
100% on that.
curious if so print student data, that's the object that's printing, and then print a student, that's the name Doug. That's the well, yeah, because it's printing the dunder string.
Yeah,
Or the
exactly.
represent.
Exactly.
Okay. So yeah, I mean it looks like it worked then.
Okay,
Without
awesome.
it.
Yeah, I may have been wrong there, and we don't need to do the named arguments then. I always get a little nervous because like name, age, role, like what if what I'm not 100% on is if it's not named arguments, what if we change the order here?
Right.
And this order is not the same as in student CSV. I'm
Right.
not 100% if that would work or not.
Okay. And well, and then also I guess like if for some reason it was missing some data, like they didn't have a school ID, then it would be all sorts of jacked up, wouldn't it?
Possibly, yes. I saw a couple other questions. What other questions does folks have?
Yeah, so I think that was just a happy accident. Can we test if you did not make them name arguments and just switch name and age right there? I
Do not want to do that because I want to make sure that we have enough time to cover building out the rest of the demo.
Okay.
Yeah, I'm sorry. I think that's something that you guys can easily test on your own time, and I'll share this code up. Athena, yes, what's up?
Are
It's a
we
great
needing to
question, though.
import? Are we needing to import the CSV stuff for it to run?
Oh, you mean specifically this? This line right here on line 4? Or do you mean the CSV file itself?
Yeah, no, that was it. My bad.
The CSV file itself, we don't import. We use this with open statement and we give it the relative path to the file.
Okay.
This import was here more, we don't need to import it, but it helps VS Code not show like little squigglies for certain things. So I added it there for just explicitness.
For best practice, do we put this at the bottom of our file or at the top of the file?
We are actually going to move this into a class method on the student class, and I think that's what I want to show next. Yeah, that's a great question. Because really what I want to do is maybe I want to have this become part of the student class. Though I will say we don't explicitly need it as a class method. We could actually use this to build up our students, but I think it will be good to see. In terms of if we weren't doing it, you would just want to put this wherever we need it, because we probably need to import the CSV data before we do stuff like run the terminal program where the user can see a list of all the students. So there's no particular best practice around it. I think what I will do though is let's go ahead and grab this same pattern and do it with not students, but staff. So here, I just need to change this to staff. And this is where, you know, maybe like the names aren't worth it because, you know, now it's just like more stuff to change that we don't really need. And I am going to go over to the staff class. And I am going to modify this to be named arguments because I do like that pattern. And the nice thing about named arguments is you can have a default and it doesn't matter what order you pass the arguments in which can be nice. And let's see if this runs as well. And now we have a whole bunch of staff printed out. And I do recommend, if it makes it easier, like prototype this stuff in the runner, just like I did before we move it into a class method or anything else. And my apologies, just one moment, folks. I'm gonna figure out, I think, kind of what we want to look at next. I think yeah, let's go ahead and let's actually turn this into class methods for students and for staff. So what I'm going to do here is, let's say we want to make a class method. To import all the students. from the CSV file. And they're going to go on this class attribute all students list, which is going to start out as an empty list. But just like we've kind of seen in our other code, it's going to end up with a list of all the students. So I know that I create class method, right? And let's just name it all students. And for the moment, I'm going to put pass here. And I'm going to write out a little bit of skeleton code, and then we can move this over bit by bit. And let me just close out this other stuff, just so we have less to look at as we're doing this. And let's go up here. We've got school, we've got students, we've got staff. So what we want to do now is we're going to want to do something like this. Student, all students. And I think I'll just leave the method name the same for now, for simplicity, and to try and keep it kind of in line with the tutorial code. And I want to be able to call this, and this will import all students, or let me rephrase this. We're going to get all the students from the CSV file and add them to all students list. So I think the one thing I do want to do that's going to be a little different is I'm going to pass in the path to the file as an argument. So then this will look like this: ./data/students.csv. And let's go ahead and copy this code over and see how we do. So I am just going to, in fact, copy all this stuff and paste it in. And let's make this a bit bigger so we can look at it. And I'll close this out for the moment so we can focus on this. And I'm going to get my indentation right. I'm going to get rid of this pass statement over here. And I'm going to change this from being hard-coded to the path to the file. And so Python, this will run fine, but I just don't like squigglies if I don't need them. So doing import CSV, this is really just to tell VS Code we're getting the CSV from the Python standard library, and it gives me this nice, when I hover over it, I get the autocomplete stuff. And so now we pass the path to the file. We're running this class method in runner py, so it's getting run from the same spot. So the relative path should be okay. And I don't think anything else in this code needs to change. Now, we're not adding the students to the all student list yet, but let's at least run this in runner py and see if it works. And I'm going to go ahead and comment out all this stuff. And let's see what happens.
Hey, Adam, it looks like Tom has a question.
Oh, awesome. Let me run this and then let's tackle questions. So good news, it ran and no errors. And Kara, thank you so much. Tom, yes, what's up?
I just had a quick question. So do we still want the all students list in the student class? And then also to like instantiate a school
Yeah.
instance in our okay.
We
Thank
do.
you.
Yeah, and that is a good question. And there are different design decisions that could be made. And remind me when we get to kind of hooking this up to the school class, and we can talk about those when we see those. Yeah, that's a good question. Mainly, in part, I want to do this to demonstrate a class method and class attributes. But yeah, it's a good question, and you're correct that there's multiple valid design approaches here. What other questions do folks have? Cool. So, the thing I want to point out is, like, sometimes when you're prototyping, doing it the simpler, easier way, like I just wrote out all this code in the runner. Sometimes that can help a lot, and then I kind of bring it into the class method. It really depends. We could have added it here. I just thought that was like a nice way to illustrate it. And now we just need to append to all students list, right? And we can do that right here with, I do need to make one change. This is not self. The variable name doesn't matter, but it would get super confusing. This is the class. So now we do class, all students list, append a student. And I'm going to get rid of this print statement. And I'm going to get rid of this print statement. And what I'm also going to do is I'm going to return the list of all the students, because maybe we want to use that somewhere else. Like maybe we want to pass that to the school class at some point. And so now, like, after I do this, I should also be able to do print student, all students list, and we should see a list of all our students. So let's see what happens. And indeed, we've got a bunch of students printed out here coming from this print statement on line 14. And let's just add all students to make sure that the print statement is coming from where I think it is. And lo and behold, we're good. It looks like the all students, because it's a list, so they're just all in one big list. They're not on separate lines. That confused me a little bit, but we're good to go. And in fact, I'm going to comment out Alice and Bob because we don't really need them anymore, and they're just cluttering stuff up. So we've made some pretty good progress here. We're able to import all the students. And let's follow the same pattern to import all the staff. And maybe someone could help navigate me in doing this. Does anyone want to volunteer to do a little navigation? Or I can just sort of drive and navigate if that's easier. So this is the great thing about like doing it once. I'm just going to use the code I wrote here as guide code. And let's just create this class method up here. So I need all staff is going to be an empty list. I'm going to create a class method. It's going to be named all staff. I'm going to pass it the path to the file. And at this point, I'm going to copy over my other code from runner py. This gets changed to path to file. I'm going to import CSV to get rid of the squigglies. And class all staff, let's name this all staff list. And we're going to add our staff member and get rid of these print statements. And return the all staff list in case we want to use it anywhere when we import it. And I'll leave that commented out until I've confirmed that this code works. And let's run our runner and see what happens. And now we've got all of our staff as well. So we have made a lot of progress here in our program. We've got the school class. We've got the student class. We create students from CSV data. And we do the same for staff. And we may not have needed a person class, you know, as someone pointed out before, a lot of that is for learning purposes. Tom, I think that might have been you. And you're not wrong there. It does, if we want to add more methods and stuff later on, it does make things more useful. Tyler, yes, sir.
I just had a question on like the output when you go to print like the all students list, it's printing the dunder string, correct? But what is actually in all students list is the student object. That means I guess that it would mean that it did add the student object instances to the student list successfully because it's printing the dunder string, right?
Correct. Yeah, if we
Okay.
go to staff.
Or sorry, the repper.
Yeah, the repper. Exactly. Yeah, that's exactly it. We're adding an instance of each student and an instance of each staff, and it's printing out the dunder repper. Exactly.
Okay. All right.
DJ, yes, sir.
Is it, just not to derail us too much, is it a best practice to put the class methods above the constructor, or is this for just demonstration purpose?
I think it is. It is. That's how I've seen it done for static methods. Because the static method is like for the whole class. I'm not 100% for the class method if it's best practice to put it above the constructor or not, to be honest. I need to double check there. For static methods, I think it is. And actually to talk about static methods, let me just quickly build a static method. I don't think we'll use it that much in the rest of our code, but just to review and also give a good example of like what a static method is good for. Let's make a static method and let's call it actually, you know, the reality is this doesn't have to be a static method. Actually, no, we can. Let's do this. Let's say we have staff roles and it's a list. And let's quickly go to our staff CSV file. And this staff roles could be a dictionary as well. I think that's really it's sort of dealer's choice. Whether this is a list or a dictionary. I'm going to roll with the list just because I've started typing it that way. To show like why this might make sense. Yeah, I think I'll just keep it as a list for the moment. And actually this should be lowercase. Principal, janitor, teacher, and that's it. And let's say we now make a static method named def is valid role. And let's pass in role. And if role lower, I hope I have that right. Can someone remind me if this is right, or is it like lower and then you pass in role as the argument? And
I think that's right.
Yeah. You know, the irony is I'm writing this as a static method, but now that I'm doing this, I'm seeing, well, hey, maybe this should be a class method because I'm referring to staff roles. I'll finish it as a static method. Right? If it's in here, we return true. Otherwise, we return false. not a huge difference of big deal if this is a static or a class method. The difference becomes with a class method, I can just do that, right? And I do want to have this be uppercase to follow naming conventions for constant variables. It doesn't change the code at all. So this is this is a good example of what you might write like a static or a class method for, just to kind of demonstrate that. And I know folks had asked about getters and setters. I think I will try to come back to that later because I want to make sure that we can get through more of this application. You know, I think like to finish up the class method, static method discussion, I don't know if anyone has any good ideas for static method, like a sort of utility method on student or staff that wouldn't involve like accessing the class at all. I'm trying to think if there's one at the moment. Oh, let me catch up on the chat.
Would making a class method that just changes whatever you input it into to lowercase, like for storing the data, make any sense? Would that be like a class method?
No, you'd probably just want to do that wherever you're actually saving the data. I mean,
Will
it
we
might,
be-
it just depends.
I know this is in part 3 of the assignment, but will we be going over adding a student to the CSV file? Or are we going to do that on our own?
Oh, we can, yeah, we should keep going and kind of, I think, build more stuff out. I don't know if we're going to add a student to the CSV file or just add them sort of to our students class. But yeah, let's build out more of this application. So I think I've kind of been poking around this part. Nathan, yes, right now the CSV reader is read only, but if we wanted to write to the CSV file, we wouldn't do it in this method anyway, right? Because this method is explicitly about getting everyone who's in there and adding it to them. You know, if I was going to add like def add staff to CSV, and here I'll go, you know, if we did decide we wanted to do this, I would be opening the file again. Right? I wouldn't be doing it. Right. I'm not going to import people and add people in the same method because those are like different features and you use them at different times.
And is that just like for this assignment that we won't add to the CSV? Or just like in general, if you're creating an application like this, you're just going to add it to your class list?
It is just going to depend on what your program is doing. Sometimes you might want to write to a file. A lot of the times for assignments and assessments, mostly the files are data that you use and you just want to read from them and you don't need to write to them.
Okay, thanks.
Yeah, totally. I think we've covered a lot of ground with these classes. I'm not sure if there's much else we need to tackle. There is maybe loading staff and students into the school. And there is a good discussion to be had around like, does this all staff method belong on the school class instead? Maybe you can make an argument either way. Let's go ahead and add a little bit more to our school class though with what we have.
Hey, Adam, Tyler's got his hand up.
Oh, thank you. What's up, Tyler?
So I just had a quick question. So like, is this a common, because we the way we named like in our people classes, our attributes is obviously it's dependent on how the data is structured that we want to import Because like if name, like I tried, like if name was uppercase in the CSV, it won't import that, and then actually, you know, the dict reader can't grab it and put it into our class. Is this like a common thing to where like you're just going to be given data and you just have to work with how it's structured, and then
Yes.
I guess
Short answer
because
is
this seems
yes.
like a simulation of like, you know, school is switching to a new system. Here's all the data they already have.
Yeah.
So is that
Yeah, the answer to your question is yes, absolutely.
okay?
You join a company, the database already exists, all those tables and columns are already there. You're working at a school, they've got a ton of stuff in Excel and they need to export it and load it into the database. You know, like most of the times you will be working on systems and stuff where like code and data already exists. Otherwise,
Okay, so
there's not a lot, you know, if you think about it, like it we're writing programs to deal with stuff that's already out there in the world and do something with it and help other people accomplish something. You know what I mean? So it's
right.
like it you know, it's very rare that someone may say, we're going to create a brand new school and you get to write everything for it from scratch. Yeah, the whole point is the data is out there in the real world, and the data is actually more important than the logic. So it's very normal that you get data in a certain format and stuff like that.
Okay, because it just made sense to me, or I kind of realized that like really what we're doing is we're just making a class to match a data structure so that we can
Exactly.
manipulate that data.
Exactly.
Okay.
Yeah. That's exactly it. Like data is more important than logic, and most of the time, like there's going to be stuff out there that already exists that we're working with. So we've done most of the work in staff and school, or staff and student. Yeah, and that's a good question. And just like the more and more code you write, the more and more you realize that it's like you're working within bigger frameworks. Like when we get to React and Django, projects have to have certain directory structures and files have to be named certain ways because we're working with libraries that other people have written and that are expecting code to be structured a certain way. So I will say the nice thing about making the decision to have all the staff import stuff here is it makes this school class like a lot simpler. There's not much going on here. Now I did create this path to file argument that we do need to use here. So we do need to pass these arguments in. It might be worth making these named arguments because this is really easy to forget. And in fact, I think I'll do it like this. Because now it's harder for me to make that mistake. If we had wanted to, we could have taken this method, right, and put it on the school class. I think there is a case to be made for that. But both are good design decisions, and it's a little bit of dealer's choice, I would say. And let's just name this students and this one staff. And let me open up school here. And let's go to the runner here and see how to use this. So now the name is Ridgemont High. The students file path is /data/students staff.csv. And the staff file path is /data/staff CSV. And let's see if this works. And if it does, we should see staff and students printed out. And let me go ahead and comment this out in our runner and comment this out in our runner as well. And lo and behold, we have students and staff. So I just want to pause and check it in and see if folks have any questions. Okay, cool. So this is really all of part one of the assignment plus and then some, right? We really did add a bit of extra stuff in here. And if I poke around and we kind of see what we have lined up next, it's really building out the terminal interface, right? What would you like to do? List all students, view individual students, add a student, remove a student. And if we kind of look over here, just to look over the intent, we see a lot that's familiar. There was a really good question about adding students, which we don't even kind of cover in this part, but I believe we cover in the final part of this exercise. And we may not necessarily want to add a student to the CSV file. We may just add them to like the list of students in memory. We can cross that bridge of writing to the CSV file later. I think we should get to building out the terminal interface. I know folks were also curious about getters and setters. So before we build out the terminal interface, maybe let's look at the code we have to see if there's anything that like might be a useful getter or setter to write. To be honest, right now with students and staff, there's not a ton of things that like the program necessarily needs as a getter or a setter. You know, like a school ID, an int, changing the student password. That could be a good example to write a getter, like a getter and a setter for. So that's something that might change. So maybe let's modify the student we'll use student password as an example of the getter and the setter. So here we set the password like this. And as we've seen, we want to be able to indicate to other programmers that we're not supposed to access self._password directly, that we want you to use the getter and the setter for it. And just to follow the convention that we've been showing for learning purposes, I think I will keep my getter named get password. If I wanted to, I could just name it password, and that does have a little bit of elegance to it, but just explicitly so that we can see what's going on. Well, I'll do it this way, and then if folks have questions, we can do it the other way. So here's now, you know, do we really want to show someone's password? Maybe not. Maybe we want to like require someone to confirm their student ID before we show them the password. Would I really want this in a getter? Probably not. This is actually probably this is too much logic that this really would belong in its own method. But yeah, in fact, I wouldn't want to put this in a getter at all. If I wanted to go down this road, I would write a method like validate student or something like that. So I think for password, I will just keep it simple and we will just return an F string with the password. Now a setter, the pattern is the name of the getter dot setter. And if I name it password again, then we can add some logic here, right? And I can do self dot underscore password equals new password. And here, maybe I do want to do something like if new password, if like the length of the new password is less than 5, print password must be at least 5 characters long. Right, I wouldn't actually want to do it this way, but just as an example of adding some validation logic to setters, we can see this here. So again, this example is a little contrived, but that's okay because the goal here is to really practice using getters and setters. And a getter is for when we want to maybe present information in a different way than we store it. And a setter is for when we maybe have an extra validation step for when we're modifying that information. And so now in my code, you know, I could do something like, in fact, let's just go ahead and run this in the runner because we have school, staff, students. So let's grab a student. So let's do school, students. Let's just grab the first student. Right. And now if I print a student password, I should see their password. And now if I do a student dot password equals this, we should get an error message. So let's see if I got this right. And I'll comment this stuff out for the time being so we can see what's going on. So we can ignore this print statement. This is just from lurking somewhere in old code over here. In fact, I'll comment that out. And we can see when I print password, it uses the getter. And then when I use the setter, it does indeed trip my validation logic. And now if I change this to like XYZ 1, 2, 3, 4, 5, and we print out the new password. Now we've changed our password. And the pattern that you've seen in most of our course material is where we explicitly name the getters and setters to help illustrate that this is a getter and this is a setter, but you can use whatever names you want, though I think in the assessment we specify what names things have to be. So you do need to follow that, but then it just looks like this. So I just want to pause and check in and see what questions folks have, maybe around getters and setters. Terrence, yes, sir.
Sorry, would you mind repeating the context in which you would employ a getter and setter one more time?
You use a getter. So first off, in the assessment, we're going to explicitly tell you what needs to be a getter or a setter. However, in general, you use a getter when we want to store information one way. I just want to store the password. But let's say I decide whenever I want to like print the password to the screen or show it, I want to show it in a different way. So here I want to show password, but maybe like maybe a student name is stored in lowercase, or maybe a person's name is lowercase, right? I always want to store a person's name lowercase for string comparison. But then what I want to do is, and let's go ahead and make a getter for name. Whenever I'm printing or sharing that name to the screen, I want to capitalize the first letter of the name. And I think that's the right method to do it, but I'm not honestly sure off the top of my head. So that's another good example of when you'd want to use a getter. And then the setter is for like additional validation logic, like for changing the password. We want to add in some logic that the password has to be at least a couple characters long.
Thank you.
Yeah, absolutely. Good question. There are some other uses of getters and setters, but other reasons to use them, but they're a little outside scope. Any other getter setter related questions? Okay, cool. I'm thinking maybe we should get to building some of the terminal interface, because I think that will be useful. And then we can get to like adding and deleting students. Does that sound good to folks? Cool. And in the interest of time, some parts of the terminal interface I may keep on the simple side. How are folks feeling about like class methods and static methods? Are we feeling a bit better from having like gone over that a bit with
Could you actually go over that just real quick again of how like you actually accessed the class methods to like get the CSV data, and then how you access that through the school?
You know, I actually don't. I apologize. I don't think I have time to go over that right now, and
Okay.
all this code will be pushed up. So I think you'll have plenty of examples of that. Because I do want to make sure we get to some of the terminals. If there's a good opportunity to write another class method or static method along the way, I will. But you know, you can see right here, I'm using this class method that I wrote here and here to add students and staff. And this code will be there for review, and the assessment, you do have to work on it on your own. Like you can't get help from other students or TAs, but it is open book. You get to look at all the code, and you should look at all this code in demos and notes and in the curriculum repo and stuff. And hopefully you all have been looking at all of that code as reference when you've been working on assignments as well. That's you know what it's there for. So let's add some terminal logic. So as a reminder, this is what we want our program to do, right? What would you like to do? List all students, view individual students, add a student, remove a student, quit. So I'm gonna kind of make a dirt simple terminal with this in our runner. And I'm just gonna close out some of our other code. So we just have the runner to look at. And I have all these, you know, all of these like print statements that have sort of been like my own informal testing. I'll just kind of get all this out of the way. So let's make our terminal. And I'm gonna try to use names consistently, like main menu message, user main menu input to help make my code more readable. And let's just go ahead and print this to make sure that it prints. And let's add some if statements. And I'm just going to add pass. And we're just going to make a bunch of else ifs. And this is going to be 1, 2, 3, 4, 5. And let's see here, if user main menu input 5 pass, that should be an else if as well. And then we'll do else, right? Invalid input, please. Right, 1, 2, 3, set to select option. And I think I do want to wrap all of this in a function, which I've seen many of you do. And I think it's not the worst coding pattern. And I think I'm going to use the verb display to indicate when I'm showing a menu to the user that they can make a choice from. So let's name this display main menu. I don't think it needs any arguments right now. And while I kind of like the while loop approach, this one is simple and it works of just calling my own method again, right? And this is our invalid input. And now this should work. And now for option 5, which is quit, I do want to, I believe the command is exit, will end the program. So let's run this and see if I can quit my program and if the invalid input path works. And it would help if I called my display main menu method now that I did all this work. All right, run program. So what would I like to do? 7. So that works great. How about quitting? Awesome, right? So now we're off to the races. And so now I think what I'm going to do is just add a little message there to remind myself of what that is. I'm just going to make a different method for each of these things. Though some of these, to be honest, there's not even that much work to be done. But I think this makes it simple and gives me a good pattern in my code. I could eventually refactor all of this into a class if I wanted. But if I just make a display function for each thing the user selects, I think I'm going to make my life really easy. Right. So actually, let me just add those as comments here as a guide for me. So I'm going to want display view individual students. Display add students. And I want the word menu at the end because I'm really into consistent naming for myself when I read my own code to help me reason about what my code is, what the job of this function is, and for other programmers. Right? The job of these methods is not to remove a student or add a student, it is to handle the terminal menu. And quit, I don't really need one for because that one is really simple. And I can start building a bit of this out, right? How about student, let's just do student name. Add a student. For now, I'll just print add student, just so I know it's there. For now, I'll just print remove student. So I made, again, I really like making like skeleton code because now here in my main menu, display.
You're missing that logic, Adam.
Which one?
The display all students.
Oh, I am totally missing all students. That is absolutely number one because I got rid of it up here. Thank you so much, DJ. Display all students menu. And again, I don't probably need a method for display all students, but I have a pattern that I like. So I'm going to follow it so I don't have to think about it. And so that my code is easier to read. And because what you'll find is the more you set up and follow patterns, the more you discover, the easier you make it to refactor your code to make it more organized or better or less duplication, you know, of concerns or turn it into a class. So I'm a fan of it, even if maybe I'll get rid of stuff later. It also makes my decision making easier. I don't have to think about, do I need a method for this or not? I'm just deciding, all right, every menu gets its own function. And option 4 is remove a student. And we don't need any of these passes. And quit is the only one where I didn't do that because that one is a bit more straightforward and it's already there. What this also lets me do is test my code. Display all students works and it quits because I haven't had my code do anything else yet. That does what I want. That does what I want. That does what I want. And now, again, yes, I've added extra layers, but my code is dirt simple to reason about and write about. And maybe I decide that after each of these, I want to return the user to the main menu. All I have to do now is here, I just add display main menu here. I have a really nice separation of concerns. Display student menu doesn't have to worry about bringing the person back to the main menu. I'm doing that in my main if statement. And in fact, I can test this again. Right. So again, I think this is really the advantage of the single responsibility principle. One function does one job. Separation of concerns. Combine or compose these things together. You absolutely could do this as a class or with a class as well if you wanted to. And now, like, if we go back up, like school, we have all the students, right? So here, like maybe all I need to do for display all students to get started here is print. So actually, this does raise a good point of I am sort of depending on school being created here, which is okay. But just to illustrate, like, if I wanted to, I could pass in a school as an argument to this method, right? Depending on how I restructured my code, I have a lot of flexibility. For now, I'm just going to use the school that I define way up here. And in fact, we don't even need this import CSV anymore, but I'll leave it. So for this, for the moment, let's just print school dot students. Student name, what is the name of the student you want to view? Well, then I get the student name. Well, let's maybe modify our student class now. And let's maybe make a class method. And maybe let's name it something like get student by name. And I'm now, again, if we had had the students in a dictionary, it would have made this a little easier, but this is not necessarily the end of the world. Right off, I am going to, well, let's just do for student in class dot all students list. If name lower equals student lower. And this should be student dot name lower. I return the student. Else return, let's return none. And then what I can do here is what's the name of the student I want to view? All right, I've got their name. Let's do student equals student dot get student by name. In fact, let's just change this to name to make it a little shorter and easier. If student is none, print that student isn't at this school. Else print student. And let's see if this actually works. And, you know, folks, I apologize. I got sucked into this and we ran into retro time. So right after this, we'll have to take 5 and then kick off our retro. But let's try viewing an individual student. It should be by ID instead of name, but that's okay. Bob isn't at this school. Let's find a student who is. Lisa. And I have an error. Student object has no attribute password. Did you mean password? Ah, this raises a very good point about the dangers of refactoring. When we added our getter and setter for password, I did not update the REPR method. Because I named my getter get password. If this was just plain password, it'd be fine. So what we'll do for simplicity is we'll just do that. And now we've got our student. So I do apologize that we have to wrap. I hope that was helpful, and I will be pushing all this code. Most of all, I hope seeing how just breaking stuff into small, specific, individual steps makes everything else easier.